Hello, welcome to my artificial intelligence Euchre project. Um, this Euchre project, my goal was to implement different heuristics um, to have them play against each other in a Euchre game. And I implemented one heuristic for picking trump and three for playing cards throughout the round. I only implemented one uh, for picking trump because I just wanted to focus on playing cards because I think um, that was that was kind of like the bulk of the game. But nevertheless, picking Trump is still important. That was just not my focus for this project. Um, the way I have my main setup is uh, basically we will loop through a bunch of different games. So we'll start a bunch of different games, and it'll play the game, and based on a certain heuristic, which is chosen right here, and it will play and it'll find its winner and it'll increment the winners. And then at the very end of my file here, it'll see the heuristic. Well, it'll print out the averages over those 50 games of how well that heuristic did against another heuristic. So for this first one, it'd be heuristic 0 versus heuristic 0. Um, so this would be team 1 or team 0, and this would be team 2. So both of them have the same heuristic. This next one over here would have one has the first heuristic, and this is 1 versus 1, and 2 versus 0, and 2 versus 1. So that's kind of how I have my main setup. Um, so it statistically gives an average of how well the heuristic does against each other. In my make file, I have a little info thing that just says all the different things you can do with it. So I implemented a sequential main and a parallel main. The reason I did this is because one of the heuristics that I use, the third one, is a backtracking kind of heuristic, which takes quite a bit of time. So when doing like 10,000 games or something, I can drastically speed it up by using parallel. Um, but I still threw the sequential in here just in case. Right now, my sequential default is at 50, and my parallel is at 1000, but I did test my parallel on 10,000 to get a most accurate reading. Um, and then I also have an example here. Example, this example isn't really testing, it's not comparing the different heuristics. This example is just showing, giving a visual of the actual game being played. I just have it set to default heuristics, which is just a random card, so nothing spectacular or anything. Um, but it shows the process of how the game executes. So you can just do make example and then and the way I have the main set up here um, to use. So here it says the dealer was stuck and chose diamonds as trump. So I implemented sticking the dealer and not reshuffling. I know some people play differently, but so this means the dealer got stuck. So everyone turned down the first card, including the dealer, and then no one chose trump. So that's what this case means. And it shows who the dealer is. The dealer's chosen at random. This shows what the current trump is. This says who's winning the table as like who's winning when someone lays a card down, but no cards are laid down, so no one's winning. Table size, there's nothing on the table. Um, this shows all the players that have like laid a card on a table and like what order they're in. And this shows whose turn it currently is. And then here, this shows all the cards. Each player obviously has all their cards, and the kitty is the four cards that are like face up or the four cards that are sitting in the middle at the beginning. And this is the card that was turned down, which is the Queen of Spades. Um, so no one chose spades, but That's I mean, that's kind of how I have my print set up. And the reason I print out all these cards, again, is just for visual. Obviously, the computer, when it does its evaluation, doesn't actually know every card. I have it shuffled for that. But this is just for our sake that we can see. And so we can see it's player two's turn. And then when they play here, going down to the next thing, it shows player two played a king of clubs. And then it player three's turn. And now the player winning table is player two because he's the first one that played. He's currently winning. And we can see it kind of continues along. And then here it'll be player's one turn and he plays a card and then it gets reset. And it looks like player one won his turn here and it's player one's turn again. And so he plays another card. And you can kind of see that these cards are getting taken away from here. And as you scroll down throughout the turns, it will end up no one has any cards left. It's just left in the kitty, and it'll say who won. So that's kind of, I just wanted to show the example in case, you wanted to look at that or kind of in that way. Oh, another thing to note about the example is due to all the prints and everything, I added some print statements, which is into the CC file to make it a little bit easier. And so I have a little separate CC file. That way, when we're doing the statistics of stuff, it doesn't get interfered with that. So that's the reason why this uses a separate CC. Um, so on the P main sequential, one is parallel. Right now I have 4 threads using it. This could be changed if you wanted to use more or less. Um, I've tested it on 1,000. Well, I've tested on 1,000 and 10,000. And right now I have it set for 1,000, but 1,000 games. But I also tested it on 10,000, which I can show the images right here. So let me make this as big as I can. Don't need that up right now. So this is kind of like what an output would look like. It would output the number of games, the heuristic used, and the percentage of just team one, because team one is the one that I used just as like my default. Obviously, the other team won the 100 minus this amount of percent. But this shows the percentage of each heuristic. So that's the 1,000 evaluation, and then this is the 10,000 evaluation. So that's kind of that's like how I have my main setup. Um, okay, so now I'm gonna go ahead and talk about how I set up everything. This is already documented somewhat in my report, but I'm gonna try and give more detail in this. But if you just wanted to save time and you felt like you understood it in the report, then you can stop watching now. But I'm gonna go ahead and continue. So so first I'm just gonna look at the card.h. So this is just defining a card. So here we had a bunch of different ranks, and I did the bower left, bower right, just because it was easier to do it this way. Suits, and then I have a no suit for certain situations. And a card is just a rank in a suit. I'll try and go somewhat quickly through this, but try and give as much detail as I can. Through my game.h, I think I might. Well, all right. So the assignment operator, the constructor, um, these are some of the defaults. They're more or less pretty. It would make sense for those. There's nothing too complicated about that. Change heuristics of players. So right now there's 3 heuristics. This is only heuristics for playing a card, and this would be after picking trump. And you can put either 0, 1, or 2. And 0 is a random, like pick a random card. 2 is pick a card that's going to win if you have the option to win. And 3 is going to use a backtracking kind of algorithm that we can talk about later. But this just changes the smartness of how smart the players are. The start Um, Actually, when did I open the CC for this? The start just initializes the shuffling and um, it just initializes the shuffling and just really the beginning it deals out everyone, picks a random dealer, and it doesn't do anything more than that. That's all it does. Play to trump is actually um, that plays until trump is picked, and then we're gonna wait to play a card. So no one plays any card till here, but this that does that. The shuffle one, this shuffle one basically it's used in the backtracking algorithm, and basically it'll shuffle all the cards that the current player can't see, and that way it mixes it up, and the algorithm doesn't know what the cards are. Um, so that's the point of that thing. Play to end is just finishing the game, basically. Get winner, this just returns the winner of the game. And then print game is just the print function that we talked about earlier. So I can quickly go over some of this stuff. So this is just the players of the game, right? They have that's like their hand. The kitty is the 4 cards that are on the table at the beginning. The last card is what I used. So the last card in the vector is what I used for the face-up card. These are used cards. Those are basically just junk that you've already played with. Um, these are the cards that are currently being played in the like little round. This is the trick count. Keep track of who's winning. This is the dealer. Um, this keeps track of what was turned down for Trump. Um, this is saying if the Trump has been picked, really, if the game has started. This is just the heuristic for each player. This is the winner. This is whose turn is currently it is. This is what currently is Trump. So these are used during the actual like playing a card. Who, what's the current lead of Trump? Who's winning the table? Who led the turn? And then these two things are things that I used for printing. So it's just like an easier way to print out. And then this is the evaluating to see if the dealer should pick it up based on someone's turn. This is the evaluating based on if you should pick Trump. So if the dealer turns it down and it's your turn to pick Trump, or if you're the dealer and you're stuck, you have to choose a Trump. But that's what this function does. Dealer pickup actually just has the dealer pick up the card and does everything that it needs to do when you do that. This update Bowers. So the way I kind of set up my thing here is my suits or my ranks. I had the Bowers put in like this because it'd be easier to compare. So I just had the Bower left and Bower right for changing them. So when it updates the Bowers, it will find out when Trump is declared. It'll update these things to what they need to be, and it'll update the Bower left to the correct suit since the suit changes. Is card greater than? This is used. So this is kind of important. This one's only used in after Trump is declared, and this one's only used before Trump is declared. This one um, is used during that time, um, during playing a card, because it takes into account what card was led and if you can trump that or not. Or even if your cards rank higher, it's not going to top it if it's not the right suit or not trump. So, and then this one's used in the evaluation for picking trump. And then this simulation. So this is the simulation. The only difference between the play to end simulation and the play to end, which is up here, is that the play to end generates legal moves and and you try and get the best move by calling the rank legal moves. This play to end simulation just takes in the best move right away. That's the only difference between them, and it's just used for the simulation. It was best for me to do it this way, um, or the way that I came up with it at least. This legal moves just returns all the legal moves that are someone can do. And then rank legal moves is kind of where the heuristics of playing a card come into play, and it returns the best move out of all the legal moves that it has. Um, so that's like a brief, I guess that's like a brief summary of all the um, that's a brief summary of all the functions. I can go into a little bit more in depth to places where I think they're needed here. I did use some of these algorithms here, or some of these libraries to almost all these libraries, well, most of them are used just for the shuffling and getting like a seed, and this algorithm is also used for the shuffle. And then I put these two links in here just in case. I still have it in my report, but I think the constructor is pretty self-explanatory. So shuffles, deals the card, shows the face-up kitty card, and then randomly selects the dealer. This is where I use the seed. I found this off of Stack Overflow. I cited that in my report. So this is just making the kitty. So here I can kind of explain this one. This one's a little bit more dense. So play to trump. Um, it basically checks until we choose a trump. Because it's a recursive function, so it'll keep playing until we get to trump. So that's what this if statement's here for. If the game is started, then we're done with this. Um, so this is checking to see if it's our first time around. If it's our first time around, we want to see if the dealer's going to pick it up, and that's what this function does. So if the function says yes, then here we're going to pick it up. So this updates the suit. Dealer actually picks it up, updates the bowers for trump, moves turn, and game started. Otherwise, this is just a pass. And so now down here we're saying, oh, the first card was turned down. So now we're going to do, um, this is checking to see if if it's not the dealer's turn and we're time to choose trump, then we're going to choose trump. If it is the dealer's turn, we're stuck. So we have to do it this certain way, basically. Um, that's probably that function. So the way I did evaluate pick it up, this could be changed to have a better AI, um, but this solely goes off of the number of trump um, that someone has. So if you and your teammate, if your dealer's the teammate, you can have 3 trump, but if the dealer's not your teammate and you want to tell them to pick it up, you got to have at least 4. But this doesn't take into account rank or anything like that. So this is definitely a function that I in the future could implement more of. This is just the dealer picking it up. Um, this is a little something here. It finds the worst card. That's what this function does right here. So this is also a little bit of intelligence, which we'll see down here. So this checks to see if it's trump or not, and then it checks rank. But really, you could have more AI in here because sometimes you want to talk about, or sometimes you want to think maybe I only want to have a 2 suited hand. That way, I'm more likely to be able to play trump later. So that's something that could be added, but I didn't have the time to get around to it. But this side of the picking trump was not my main focus too for this project, but it is definitely something that is important and could be used. This just updates the bowers and the kitty. So yeah, basically this one just goes through the whole deck and just updates the rank if it's needed. Choose trump. This is also an intelligent function, is what I'd call it, I guess. It's where you can implement more information stuff. So it returns a suit, and here it's saying if the dealer has to pick, then it's going to pick its best one. So it has to pick. So it's going to pick because we're not choosing Trump on the pickup because that's what the other function's for. And then if it's not the dealer, then we can either, if we have three or more, we can choose it. Otherwise, we're going to do no suit, and this is like a pass. Um, and this is just looping for see the maximum number of trumps. So that's everything I used um, until for selecting Trump. Sorry. Here, moving to play to end. So this checks if we have a winner. It should never get here. That's why there's this error. So that was kind of just for me, I guess, but hasn't hit it yet. Um, so what this does is it gets the legal moves and then it gets the best card um, from the rank. And then this, a lot of these have to do with if you're leading or, so this, it goes to this if statement, if you're like the first person to play one down, this one if you're in between, and this one if you're the last person to play. Each one of these sections kind of has a specific thing, just like on updating the game. So almost all of them are going to push back to the table because it's what's on the table, and then you're going to erase the card. But now the player winning is this person, and this was the person that led. Go to next turn, play to end. So continue the game, and I'll just loop through here. But then, if you're not the last, um, this checks to see if the card that this person played is going to be better or not. If it is, then it'll say, "Oh, you're the new winning person," and then it kind of loops through, turn, plays again. If you're the last person to play, you kind of have to wrap up the trick round of who's picking, and you also have to update. Well, you have to update the trick amount, and then you also have to check to see if you're done with the game, if everyone's out of cards. Um, and you got to clear the table, but you also have to see who's leading the turn next. Um, so and reset. So that's a lot of reset stuff, but that's generally what this function does. It's more of this is the higher level function. Legal moves. Um, I mean, this just checks if you're following suit. Well, if you're going first, all your cards are legal. So if you're not going first, you have to check to see if the suit led. This is an error. If you're not going first and there's no suit led, there's a problem. But hasn't hit that yet. Check to see if you have a suit. So this just checks to see if you have the suit. If you do, you're pushing this back to your legal cards. But if it's empty, if you don't have a suit, then you play whatever you want. So that's kind of a self-explanatory function. Um, so here's where this is a very large function. This is the one that has all the AI or intelligence in it. So this is like the dumb or drunk person who is just picking at random. They're just doing enough to get by. So I just use this random seed here, and it just picks a random card. And this function just returns the best card out of the legal. Um, so let's see. This strategy says if you're currently using the trick, take it. Oh, okay, yeah. So this one right here. Um, so the heuristic, the second heuristic here, basically says if we're not winning, then I'm gonna play my best card. But if we are winning between me and my partner, then I'm gonna play the worst card. That's kind of what this does here. If teammate is winning, play a worst card. If other team is winning, just play a winning card. Play a winning card if you have one. If you don't, play your worst card. Um, that's kind of like what those are doing. And then this is the third heuristic, which um, is a backtracking one, and it checks to see which card creates the most amount of wins. So if you play it, it'll be the most amount of wins. So first thing here, this is just setting up like a way to count it basically. Sorry. Um, so here's one thing I wanted to highlight. So this shuffle right here, I really wanted to do this more than once. You can see I have it in a for loop, but the for loop's only once. Um, this only shuffles in the first round of it. Um, but I have to shuffle once because it it's not fair to play if you already know what all the other cards are. So the shuffling helps take that more realistic out of it. But in a better time, I guess, or a quicker way to do this thing, you can up that count and make it go a lot more, which would probably get a better choosing of the card here to get an average over multiple different kinds of shuffles rather than just one. So that's something that I kind of talk about a little bit more in my report about the speed of this, but that's kind of something that I wanted to note. Um, but for each shuffle, we want to play each card and simulate the card, and then we want to calculate if it won or not. We can calculate each win of it. And this finds the best win and then returns that. This is saying if you're not at the end of the shuffle, or you've already shuffled, basically you don't need to shuffle again, so it does the same thing. You can always add more strategies, so this is, you have an else, you can make another else if, so you can always add on. In the future, maybe I'll look into adding another one. This card is greater than. Um, this is used in the second half, or the second phase, and it is used for comparing cards. Returns true if card A is better. So the one thing that I wanted to note about this, it's pretty self-explanatory. This compares trump, this compares rank, this compares suit led. But again, you could always add a little bit more depending on if you want your hand to be two suited or one suited. That might be a benefit to you. So this could always be changed to add a little bit more. So I just wanted to point that out as well. Print game, that's pretty self-explanatory. Shuffle, so this is where it so this kind of keeps track, this little thing keeps track of which cards are removed from where. So really you could shuffle at any size, which is kind of what's needed in case your player is going second or third and someone's already played, so you have to keep track of what cards have already been played to make sure that you shuffle the right amount and everyone gets the right thing. And here's the shuffling again. This just changed the heuristic of the players. This end simulation thing is the same as the other play to end, but with this thing as already defaulted. But that's basically how I have my thing set up. I can talk about the mains again. I mean, this is sequential. It's at 50 start, and then this is at 1,000. But that's kind of how I had my thing set up. For my results, I heuristics playing against each other most of the time were pretty close to 50%. This one tended to be a little bit lower, but still pretty close. H1, which is the second heuristic actually, but H1 is the one that if it can win, it'll play the card. If it doesn't, it throws a trash card. So it does pretty well against a random opponent. And the H2, which is the backtracking one, does, I would say, decently well, almost close to 70% against a random person. Um, so that heuristic performed pretty well. And then it does 60% against someone that's just looking, or someone that's just trying to win that certain hand. So overall, the H2 was definitely performed the best. But another thing about H2 is it took much longer to do than H1 and H0 because due to the backtracking. So that's always like a trade-off to think about. Um, and there's obviously ways that I'm sure I could have sped it up with more time, kind of more pruning and ending early if you've already gotten 3 tricks and stuff like that. But that is my project. I hope you got something out of this, um, and hope you enjoyed. Thank you.